name is Jeff.
Hey Adrian. So you overslept and arrived a little late, right? Although our starter Pokemons have found their trainers, you can have Jeff. Thanks. Give me 1 sec. Jeff is a state-of-the-art robot that comes with a mounted Raspberry Pi, ultrasonic sensors, and a camera for it to see. It also comes attached with wheels, which are driven by STM32 servo motors, and it can go on a Pokemon adventure with you. I'll go on an adventure. Thank you, bro. Hi guys, Professor Mo here. Jeff communicates with our Android tablet using Bluetooth pairing with the Raspberry Pi mounted on Jeff. After connection, we have a chat log for debugging purposes, which allows us to see the messages between Jeff and the tablet. To place an obstacle in the grid, press on small X, a classic obstacle in Pokemon games. You can slide obstacles after placement too.
Hi, Professor Kai here. The obstacle placing direction can also be modified to face one of 4 possible directions, as well as to set an image ID manually. Obstacle information can be sent to the RPi, and a recognized image ID will be relayed back to us and updated on the grid map accordingly.
After receiving obstacles coordinates from the Android team, we use the Hamiltonian path to calculate the sequence of visitation from the start point. We then use an exhaustive search to produce all possible permutations of these sequences and choose the one with shortest distance. We use A* to find the shortest path to each obstacle, using G cost for travel distance to the start, H cost for estimated travel cost to the target image using Euclidean heuristics, and F cost as the sum of G and H cost. To reduce turning error, we apply a turn cost penalty, so Jeff turns only when necessary.
To facilitate the different connections of the RPi, we use Python programming. We use PySerial to be able to send movement commands to the STM. For Android, we use PyBlues to allow remote connection via Bluetooth between the Android tablet and the RPi. Lastly, for the image recognition, we use Flask to send the image taken from the RPi to a remotely connected PC through Wi-Fi.
So for the STM side of this project, me and Chen Ping will be coding the STM. First, we make sure that our turning angle is calculated and recorded down. Then we make use of the gyroscope to actually ensure that our turning angle is actually correct. So next, we incorporated the ultrasonic sensors input to ensure that our vehicle won't be knocking into the obstacles for our task.
To start off, we first upload our dataset onto RoboFlow and proceeded to start drawing the bounding box for each image and labeling the image ID. After that, we added augmentations to our images to strengthen our image detection model if anomalies were to happen. We then proceeded to train our image recognition model using YOLO v5, and finally deployed our trained model onto the RPi.
I'm not getting paid enough for this.